Okay, we're gonna let that be for now. Done. Let me check one more time. I think we look good. I'll go ahead and share my screen, start the broadcast. And let's start here for our morning announcements for your everyday life. Welcome, scholars. Let's see. No major announcements. On Monday, we worked on section 1.5. Okay, so I think we may have finished all but like maybe one or two examples, maybe three. But I do have those full recordings available in advance. So today we're going to be working on the corresponding homework for this section, all right? So we're just going to hop over to Pearson. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 9.
Start with 9. Stocky. Boy, that little random thing helps for somebody that can be indecisive like me. You know, when I want to choose this, I don't know if you guys have seen this series called The Good Place. It's like cheaty on there. I understand his struggle, but that was definitely hyperbole. You know, you got to watch the series to know what I'm talking about. But anyway, all right, this comes from section 1.5, question 33. We're asked to use transformations of a quadratic function of f of x equals x squared to graph this, right? So looking at it, it looks like we have 1, 2, 3, 4 transformations altogether. Okay. So if we were to list out the transformations, we start with the innermost nested transformation, which is that +4, and then work our way out. That +4 tells us, so basically this is saying start with the parabola, go left 4, do a vertical stretch by a factor of 2, flip it vertically, and then go down 4. Okay. Let me move this over. So let me see, if we think about here, let's just plot, I'm just going to plot some random points. Okay, then I'm going to move them. Now, if we go left 4, stretch vertically, flip it upside down, and then go down 4. So left 4 and down 4, we know that the vertex is here. So I'm just going to drag the vertex to where it needs to be. Let's see. We can track the point. What's another point? 1, 1, right? Because that's on the original graph. So let me see. If we're at the point 1, 1, or you know what? Just let's do a calculation when x is, let me see, we said -4 right here. So that's supposed to be there. So let's do a calculation when x is -3. All right, when x is -3, we get 1 squared, or yeah, we get 1 squared. So -2 minus 4 is -6. So then the point -3, -6, that should be our graph. And all I did, I mean, basically I just plotted 2 points, but I started by tracking the vertex through my transformations, starting at the origin, left 4, vertical stretch, flip it upside down, and then down 4. And then once I had the position of my vertex, then I just kind of went to the right by 1 and then calculated that point. Let's hit save. And we're going to go with that. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 9.
Okay, so since they said 9, we'll go 10. I'll check attendance again in like 10 minutes. To catch that first wave, you got to be on time, but I know I'm preaching to the choir. Okay, so begin by graphing the absolute value function, f of x equals absolute value of x, then use transformations of this graph to graph the given function. Okay, so absolute value is a v with the vertex at the origin. Again, we do these transformations working from the inside to the out. So the innermost manipulation is that +1. That tells us to go left 1. We flip it vertically, and then we go up 6. So the only one that behaves like that is B. Hey, Google, give me a random number between 1 and 20.
8.
That's fine. Graph the function using the techniques of shifting, compressing, stretching, and or reflecting. Okay. So the base function here is x cubed. Notice there's like nothing inside parentheses or inside any kind of grouping symbol. So we have 2 outside manipulations. We flip it vertically and then we go down 6. Okay. So the cubic function is here. I'm just going to click through. Okay. I just clicked anywhere. We said we flipped it vertically, so we reflect over the x-axis. And then we go a vertical shift by -6. We want to go down by 6. I'm gonna hit save and check. Again, if anything isn't clear, you just got to stop me to get my attention and we can talk about it. Hey, Google, give me a random number between 1 and 20.
Professor,
Yes.
could you show how you inputted those values into the actual, like I'm sorry, into the tool?
To the tool, okay. I'm going to hit similar question. So it'll give me the same question with different numbers. I click on this where it says click to enlarge. I'm clicking there, all right? Because the parent function is a cubic function, right? X cubed, that's the base function. The x cubed, so the upper right is linear. The left row 2 on the left column, that's absolute value. Then the next one is what? Quadratic. So a cubic function is third row left. Third row right is the log function, right? That's the general shape of a log function. So we want the cubic function, so I'm clicking on that tool, and then I just click anywhere. I'm just clicking someplace random just to activate it. Then at first, initially, I thought that I was gonna plot 3 points and then drag them into place. That's initially what I was gonna do, but when I clicked, this menu popped up. So then we just need to capture the transformations, right? So there's nothing inside our base function. So the first manipulation is that we multiply the outside by that negative. So multiplying the outside causes a vertical change. It causes it to flip vertically. So then we're going to flip it over the x-axis. Then I click back on the graph again to open this back up after selecting the reflect over the x-axis. Then the final one was that in this case, it's going to be +9. So that's outside our base function. So that moves the whole graph up 9 units. So I want to do a vertical shift up by 9 units. That's it. I'm gonna hit save. That's it. And then I hit check. Okay. So the next one it gave us was question 5. I'm just gonna go ahead and do question 5. We might blow through these. Like we are moving at the speed of light. Okay, graph this one, right? Okay, I want to get you guys feedback on this one. Okay, let me open up Zoom. All right. Let me join. That is correct. Turn off my video, don't connect my audio. Join. Stay as a participant. Let me check the chat real quick. B, okay, yes, the chat. I think the chat is the simple way to do this, right? So I think there's one vote for B. Just in the chat real quick, do you think this is A, B, C, or D? Right, just in the chat. Do you think this is A, B, C, or D? Okay, I think there's a couple of votes for B. If we discuss the transformations, okay. So first we identify the base function, right? The base function is square root function, right? Square root function, the way I remember it, it looks like the top half of a sideways parabola, right? I think all of these are top halves of a sideways parabola. So, and then notice that +2 is outside the square root. It's outside our base function. So that means it's going to cause a vertical change. It's going to follow our intuition. So this is basically saying start with the top half of a sideways parabola at the origin and then just move it up 2. I think A goes down 2, B looks like it goes up 2, C went left 2, and D went right 2. So the only one that went up 2, I can get down with B. Let me see. Just do the best you can. I'll be checking it again in 15 minutes. So just, well, I guess you can't hear this if you can't hear your audio. But yeah, just do what you need to do. Let's go with that. Okay. Hey, Google, I'm thinking it's going to say 13. You know, feel free to type in the chat.
13 is a 2011 movie directed by starring Jason Statham, Sam Riley, and Alice Barrett.
Now I feel like I need to watch that movie. Okay, let's try this again. Feel free in the chat if you want to guess the number that Google's going to choose. If you want to practice your intuition, hone your abilities or whatever. Just playing around. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 11.
Ooh, that's close. Off by 2. Let's go. Getting closer. All right. Let's see what we got here. Okay, so this function is called a step function, right? Because the graph of it looks like the stairs on the staircase. This is called the greatest integer function, right? So what this means is, it basically, we always take the greatest integer less than or equal to whatever our x value is, right? I feel like I should write it out just to explain it better. Okay, let me take some notes. Just so that when you see this symbol, you're not like, intimidated or anything. Let's go to some lines here. Can we, how do we adjust that? Let's, let me see here. Template settings. That's cool. Okay. That's fine. You know what? I think yeah, let's try this instead. Okay. And I need my futuristic thing, my little pillow here for this thing. Okay. All right, so the greatest integer, right? So again, the symbol looks something like this. Okay. This is called the greatest integer function. This basically, we always take the greatest integer less than or equal to our x value. For instance, if we think, what's the greatest integer less than or equal to, let's start with 2.9. All right. So one way to visualize this, if we were on the number line, right? Say here's 2 and here's 3, and here is 2.9. What's the integer to the left? You can type it in the chat. I'm watching the chat, right? The greatest integer is the integer to the left. So what's this result going to be? Just in the chat real quick. In other words, what's the integer to the left on the number line? 2, right? Okay. So the greatest integer less than or equal to 2.9 is 2. Let's do another one. Matter of fact, let me go like this. Up, undo. I want this, like this. Let's copy and paste. And let me just get like this. Copy. There we go. I think we're good now. Okay. So then what's the greatest integer? Say if that's 2.9, then tell me about 2.5. What's that result? What's the integer to the left, right? And use the chat. Yep. Okay. Let's keep going. And this is a good exercise. Like, so 2.5 is here, right? Okay. Let's do another one. That one was 2. What if we had, can I paste? Cool. Ow. What if we had 2.1? What's that one going to be equal to? All right. Okay. That one was going to be 2, right? What if we did 2.01? What is that one going to be equal to? That one's also going to be 2, right? What if we did 2.00001? Again, what's the integer to the left? That one is 2, okay? Right? So whenever we're between two integers, we take the integer to the left. Whenever we're on an integer, okay, can you tell me what is this result? What's the greatest integer less than or equal to 2? What's come on. Thank you. What's this result going to be equal to? Remember, this symbol is the greatest integer less than or equal to that number. So what should this result be? Okay. So whenever you have an integer in that symbol, you just take that integer, right? So the greatest integer less than or equal to 2 is 2, right? So whenever we're between two integers, we take the integer to the left. Okay, let's do this one. Tell me about the greatest integer less than or equal to, let's see if we did. Hey, Google, give me a random 2-digit number.
On the website wordwall.net, they say 7, 21, 46, 12,
Let's do 21.
14, 5, 32, 85, 27, 64, 10, 30, 11.
Hey, Google, stop. Oh my God. All right, so let's do like this. Tell me about the greatest integer less than or equal to, let's go 7.3, right? So in the chat, what do you think is this result? What's the greatest integer less than or equal to 7.3? Sorry, negative 7.3. Hey Google, play the Jeopardy theme song.
Got it. Playing Jeopardy theme song, 1 hour on YouTube.
Ooh, okay. All right, that's good, right? So hey Siri, hey Google, pause. Hey Google, pause. Thank you. Okay, right? So negative 7.3, right? If we consider it on a number line, negative 7 is here, negative 8 is here. So then 7.3, is somewhere between these two, like about here, right? So the integer to the left, this guy is going to be negative 8, okay? So then, for instance, if we did paste, so if we did the greatest, say we did negative 7.9, that one is 8, paste. Say we did negative 7.5, that one is also 8. Say we did paste negative 7.1, right? That's still between negative 8 and negative 7. So that one is also, negative 8. These are all negative 8, right? If we did paste negative 7.00001, right? That one is still negative 8. It's not until we hit paste negative 8 that it jumps over to, negative 7, right? That it becomes negative 7, right? Because all of those decimals I listed above, they're between negative 8 and negative 7. So the greatest integer less than or equal to is the integer to the left. So all those above examples are negative 8. And then once we hit negative 7, it becomes negative 7, right? Okay, that was good. So that was the backstory. And so when we graph this function, again, all the decimals between two integers collapse to the integer to the left. And then when we get to the next integer, it jumps up to that integer like a step. So we have all these like flat horizontal segments. That's why it's called a step function. Let's answer this one and then let's check our attendance. Okay. So then the greatest integer, normally when we're at 0, it's a closed circle, going off to the right. Let me see. If we say a -1 on the inside, that's going to move it to the right by 1. So, and then we did a vertical stretch by 3. So it can't be B or C because those have been compressed. And then it looks like D moved the wrong direction. We needed to move to the right instead of moving to the left. So I'm going to go with A. I'm going to go with A here. Check. Okay. All right. Let me hop over here. Just check on you guys in Zoom. That's fine. All right. Let me get these gentlemen. So if I go here, oh man, we got a lot of people. Can I find them? There's 1. There's 2. There's 3. And there's 4. Those guys. 2, 3, 4. Let them in. Okay. Yeah, the chat looks good because I was watching that already. So let me get the student. Let him in. Oh, there he is. 5. Okay. Like this. And then put it back. Cool. So we're in the chat. Not bad. Okay. Okay. So I think we got that one. Hey, Google, give me a random number between 1 and 20.
3.
3. Let's look at 3. Describe how the graph of the following function can be obtained from one of the basic graphs, right? Anybody know the name of this basic function? Begins with an R, right? In the chat, nobody? Going once, going twice. All right, this is called the reciprocal function, right? 1 over x is called the reciprocal function. So to obtain the graph of this, start with the graph of y equals 1 over x. All we did was multiply by 4. So we want to stretch it vertically by multiplying each y value by 4. Okay, so that's just basically a direct application of transformations. Transformations, to me, they don't really become second nature until you've gotten like reps in. You know, you just have to kind of keep working it and it'll sink in eventually. You know, and not that it's like, yeah, it's just for the purposes of getting through this. I mean, and honestly, I could have used it. Let's see. Yeah, I'm not really sure. Just tell them to email me and keep trying. If you can get in before we leave, then that'll be the simple thing. Just tell them to keep trying. Hey Google, give me a random number between 1 and 20.
13.
Oh, now she says 13 when I don't say nothing. Okay, let's look at 13. So we're asked to write an equation for a function that has a graph with the given characteristics. It says the shape of y equals x squared, but it's upside down, shifted right 4 units and then up 2, right? Okay, so if we start with x squared, if we move side to side, it says right. So that means we need to subtract 4. So it has to be either A or B. And then it says up 2. So the only one that goes right 4 and up 2 is B. All right, so I'm just going to go with B. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 18.
Okay, let's look at 18. It says a graph for y equals f of x is given. No formula of f is given. Make a graph of the function g with these transformations. Okay. So in the chat, feel free to put which result you think it is. Do you think it's A, B, C, or D? While I kind of talk about it. So we have our original f of x. If we do our transformations, working away from the inside to the out, right? Can anybody describe what's the first transformation? What's the innermost transformation? How does it affect the graph? What should it do? Feel free to type it in the chat or unmute yourself. Hey, Google, play the Jeopardy theme song.
A vertical shift.
Oh, no.
Jeopardy. Theme song, 1 hour on
Hey,
YouTube.
Google, stop. I need a push button so I can just press the button, right? So inside manipulation, I'm glad you said that. Inside manipulations cause a horizontal change, right? So if we have that -1 on the inside, the inside manipulations cause a horizontal change, and they're typically the reverse of our intuition. So that -1 on the inside, we should move to the right by 1 in the positive x direction by 1. So if we can track that peak. So which one, do any of these move to the right by 1? Those look like it's going by 2s. And I think it is upside down. Okay. Many of them look like they went to the right by 1. I think they all went to the right by 1. So we can't use that. Now, if we multiply the outside, now we're moving to the outside of our function. If we multiply the outside by a number between 0 and 1, should it get bigger? Should it get smaller? Should it go horizontal? Should it go vertical? Right? If inside manipulations cause a horizontal change, then the outside should cause a vertical change, and it should follow our intuition. If we multiply the outside by 1/2, it's like our y values get cut in half. So it should cause a vertical shrink, right? Vertical shrink by a factor of 1/2. So it has to be either A or C. Oh, and D was shrunk as well. Okay, so we got to keep going. We also multiplied the outside by a negative. So that causes it to flip vertically. So now it has to be either C or D. Now, C looks like it was moved up. D looks like it was moved down. So then with that +3, that tells us that we should move up by 3. So it should be C. Let's go with C. All right. I didn't get any takers on that one, but that's okay. So I tried to slow it down as best I could to try to break apart all the parts of it. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 6.
Oh, I was about to say 14 or 16. Okay, let's go 6. Okay, what's the time? We are cruising and bruising. Okay, which result do you think is, what do you think is the answer? Is it A, B, C, or D? Right, feel free to type it in the chat. Use transformations of absolute value of x to graph the function, right? We only have one manipulation. Notice it's on the inside, right? So we said something about inside manipulations and whether it follows or is the reverse of our intuition. So if this is a V-shaped graph, should the result be A, B, C, or D? Or in other words, in the chat, can you tell me which way to move? There's one vote for C. C does look like it's been moved to the right by one. Any other takers? Oh, I think I got somebody. Right? So C should be wrong. I'm going to go ahead and submit it anyway. Let's see what happens. All right? Because remember, this is what we were talking about. Okay, so when it comes to these transformations, one of the first questions you had to, the first thing I would say to do is first identify your parent function, right? The parent function was given here, absolute value, so we know the basic shape is a V. But then the next thing you got to decide, okay, the recommendation is to work your way from the inside to the out. Whenever there's a manipulation inside our basic function, it causes a horizontal change and is the reverse of our intuition, right? Because we have a +1 on the inside, intuitively, we would want to go in the positive x direction, but remember, it's the reverse on the inside. So it's like the upside down land in, what's that show on Netflix? Why can't I think of it? Not Slumberland. What's the name of that show? Netflix, the kids, the upside down. What is that place called? Strange Things, right? Stranger Things, something like that. So long story short, again, whenever we're working inside our basic function, it's because of horizontal change and it's the reverse of our intuition. I would agree that intuitively that would move to the right, but it's actually the reverse. So it should move to the left by 1 unit, right? So the only one that moved left looks like it was D, Stranger Things. Yes, let's go with that, right? So again, that just takes practice. Let me hit check. Okay, that's fine. Okay, we got a solid little over 10 minutes, honestly. Probably supposed to be like 15. Hey, Google, give me a random number between 1 and 20.
20.
Now I'm curious as to like, what are the chances of her repeating a number? And like, I guess those odds would decrease the larger the range. In the given graph, the temperature T in degrees Fahrenheit of a home is given as a function of time, T, in hours after midnight, over a 24-hour period. At what temperature is the thermostat set during daytime hours, right? The sun comes up about 6 or 7. So let's expand this, right? So in daytime hours, what temperature is that? Anybody feel like, can you give me an estimate, like typing it in the chat? If the first tick mark is 72 and the next one is 76, what's halfway between those? And then what's halfway between that? I can get down with 73. I think 73 is a reasonable result, because if it goes from 72 to 76, you would think that halfway would be 74, but then the line is halfway between the halfway mark, right? So that's a quarter, which is like a third, which is 73 in this case. So let's go with 73 and see what happens. 73 and enter. Okay, is that it? No. The thermostat is set to this many degrees overnight, okay? So then looking at this, what's the nighttime temperature? Notice this is about halfway between 56 and 60, so what's halfway between? What would you anticipate? Man, that seems freezing. Oh my goodness. 58 degrees? Are they frost giants? 58 degrees. Oh my God, it has to be, never mind. I want to be like it's a female. I don't know. It could just be me, but that just seems unbearable. Like I would have like three separate blankets, my own personal heater. That just does not seem like fun. All right. Okay, let's look at this. It says the homeowner reprograms the thermostat to T of T -8. How is this going to affect the temperature in the house? And then graph the new function. So T of T, the temperature -8, what is that going to do to the graph? What is that going to do to the graph? Let me show the options. All right. So is it the first one, second one, third one, fourth one, or how would you like to describe it? What is that going to do to the graph? Is it 1, 2, 3, or 4? Okay, there's one vote for 4. So you're saying that it's going to lower the temperature by 8 degrees. Okay. Any other takers? Going once. Going twice. Okay, I see another 4. Forever hold your peas and rice. Let's go with 4, right? So that makes sense, right? We're saying the temperature -8, so it should lower the temperature by 8 degrees. Let's go with that. Okay. What else do we have? Choose the graph that shows the temperature reduced by 8 degrees. I might need to zoom out so we can see this better. How do I get rid of that? Come on. Okay. Okay, so which is the graph of the temperature reduced by 8 degrees? Is it A? Okay, I think there's a vote for A. Let me see. So if that was 73, then we should be 65. It looks like 65. Okay, I can get down with A. Let's go with A. Check. Okay, was that it? Nope. The homeowner reprograms the thermostat to T of T quantity T plus 3. Explain how this change affects the temperature in the house. Graph this new function, okay? So now we have the T plus, with that plus 3 is inside our function. Notice when we said -8 on the outside, it did a vertical shift down in the graph, right? So now we're saying a plus 3 on the inside, right? You can either just think about it through brute force and logic, or if you apply transformations, right? If we say plus 3 on the inside, should it be the first one, second one, third one, or fourth one? Okay, there's a vote for the third one. Let's see. Oh, we said plus 3 on the inside, right? The inside is the temperature. It should. I don't think it's okay. There's another vote for the second one. Let me see. Move the temperature change 3 hours earlier to the. We said plus 3, so it should go to the left. I think that makes sense. I can get down with the second one, right? Let's go with 2. Let's go with 2 and see what happens. Check. Okay. And then so graphically, again, we said plus 3 on the inside. So then which graph is going to be correct? Should it be A, B, C, or D? A poll would be nice. This would be really good for a poll. Let me give me just a moment. Let's see if I can activate this poll. It takes a little bit of effort. I might have to log out of my phone. I know it can work, and it's smoother, and we get a lot of feedback. Let me see if I can get it to work though. If I go to more polls and quizzes, you suck. Okay, that's fine. Let me log out of here. These are the times we all wish for. So sad. Okay, let me check and see. Let me let the student in. Let's see. He is right there. Got him, coach. Let him in. Okay. Let me see. I want to get this poll going. No, I'm not logged in. I'm logged out. Am I still on the call? Not on the call. What else can I do to get it to realize I'm not on the call? You have logged in. Your polling session is inactive. I'll be right back. Miller's fine. All right, we're back. Let me see if I can get this working first. My polar quiz. Is there another one? General multiple choice. Yes, that's exactly what I want. Okay, how do I activate it? That's the one that I want. Launch. There it is. Okay. All right, and then I just want to close this. Let me share my screen. Start the broadcast. Optimize for video. Let's hop back over here. And what we can do, we can actually pull the poll up right. Where is it? More poll. Boom. I got at least one. And then it shows me who's, come on. Okay, so there's a poll active, right? Oh, that's even better. Yes, I forgot about that. We're gonna go just like this. So now we can see the poll in live time. We got 2 for C. Let's zoom out here. I feel like one of those like auctioneers. All right, and I got 2 for D. Come on, see, nobody's like doing it. That's what it feels like. Not that I know how to do that kind of stuff or anything. All right, so we got 4 votes for D. I think it's unanimous, right? Okay, let me see. So where'd it go? I think we were looking at the wrong thing. T plus 3 to the left, right? Moves the temperature change. The temperature change was at 6. Now it should be at 3. Okay, let's go with D and see what happens. Woo-hoo. Okay, so I think if I want to use the poll again, I got 6 participants and logs who did it. Relaunch. Oh yeah, we're getting ready to have some fun now. Launch. Boom. Okay, now probably should have. Let me just end it for now, and I'll just have it. I'll have it on the swivel. I have it ready to go. Okay. Oh, we only got 5 minutes left. What a party's almost bummer. I can't get it out. We only got 5 minutes left. Party's almost over. What a bummer. Okay. Anyway, if you ever do P90X, you'll see that little clip. He will always do that in the Abra per X. I need to get back on those. I've been neglecting my body. The way I've been kind of taking care of it is trying to eat clean. Like I've been eating a lot of like fruit, mostly fruit. Since I'm not been exercising the way I normally do. And so that kind of helps me to kind of get by until I can start moving again. Let me see. Hey, Google, give me a random number between 1 and 20.
3.
3. Okay, so since we did 3, we'll go ahead and do 4. Okay. All right, this one does not have a poll. So I'm going to suppress this for right now. Graph this function. Let me zoom in some so you guys can see a little bit better, a little bit more. All right, that's decent, I guess. Hopefully that's not too zoomed in. Let's zoom out a little bit. Okay. All right. So, right, something like this, we got y equals x squared minus 5, right? Any brave soul want to come on the audio and walk me through it? I feel like you guys can handle this. X squared minus 5. Anybody want to walk me through this one? All right. So if I click on the graph, right? Which tool is, let me see, can I pull up the chat? Pull the chat up on the screen. We're going to close the poll for right now. Doing my country twang. All right. And let's slide over here so we can see. Nope. Just have it over here. Okay. Oh, I lost that too. Okay, we might have to get rid of. Oh, there we go. That's exactly what I was looking for. Okay, right. So we got x squared minus 5. So that's basically a parabola. I'm just going to click on the parabola tool. I'm just going to click anywhere and then move my points later, right? We got a minus 5. Okay. So I'm just going to say minus 5. I'm going to move it down vertically by 5 units. And that's it. I just like to hit save and check. Cool. Okay. Again, if anything isn't clear, feel free to unmute yourself. You can see the chat. I do like having the chat and little zoom on the side so we can see like the back and forth. Let's hang out for 5 minutes and then we'll call it a day. Hey, Google, give me a random number between 1 and 20.
5.
Okay, so we've done 5. The next one is 7. Let's go ahead and do 7. Okay, graph this function. Anybody feel confident in typing out like either how many transformations here? It's like, can you list out what's the base function and then how many, and then like, okay, tell me what's the base function and tell me the transformations. I'll go ahead and give you a hint. There are 2 transformations. So can anybody list out just in the chat, what's the base function and what are the 2 transformations?
The
Right.
base function is x squared. The
Okay.
transformation is going to be -3 will mean it's going to move to the right. And then
Okay.
+3 means it's going to move up 3 times.
Okay. So I heard x squared. X squared. I'm just clicking anywhere randomly. I heard go to the right by 3. So this one by 3. I'm just dragging the thing, and then I heard up by 3. Is that? I think that's okay. Stop me if I'm off. That looks good. We went right 3, up 3. I can get down with it. Let's hit save and check. I need to start throwing around some extra credit. I really do. One of these days I will. We'll let that be for now. But just it's a good thing. As long as you keep me in a good mood, that totally helps. Like it helps. If I'm like irritable and I'm like, you guys aren't engaging, when I go to do grades, I'm gonna remember that, right? It helps to just engage a little bit. Let's hang out for like 2 more minutes. Not that it has anything to do with anything. That's just how it is being a professor. But if the stuff is right, obviously I can't, I'm not gonna take anything. And I'm not trying to take anything from anybody. I just want to see you guys do well. Hey Google, give me a random number between 1 and 20.
17.
Okay, she actually chose a different one. Let's see. Okay, use the graph of y equals f of x. The graph, now we have this f of x plus 1, right? Can we, I don't know if you guys can see these. Okay, so let me start the poll real quick. If I go here, poll, that's the one I want, and launch. All right, so do you think the result is A, B, C, or D? Do you need more information, or does it need to be bigger? Which do you think is the result? The manipulation, we have a +1 on the inside. All right. So should it be A, B, C, or D? And if I go like, oh, no, you're getting worse. Well, not really. Okay, I think there's a vote for A. We got a +1 on the inside. Let me see if I can zoom in. So there we go. That's what I was trying to do. +1 on the inside. Which one of these captures a +1 on the inside? Oh, I think we are just piggybacking. Uh-oh. I don't know if we got any true critical thinkers here. We might have some TikTok followers. Uh-oh. Okay, let's see what happens if we submit A. Check. Bam. Try again. So process of elimination, right? We got a +1 on the inside. Is the inside a vertical change or a horizontal change? It's going to be horizontal, right? Come on. So if it's not A, are we getting more people still choosing A? It can't be A. All right, the only one that goes, so +1 on the inside means we move to the left by 1. So it should be B. Okay, just check B. Let's see. Final check. It's too late. You don't get credit because you submitted it after I submitted the answer. Okay, guys. Okay, critical thinking, right? Don't just piggyback. The first person that submits it isn't necessarily right. Okay, well, that was fun. We tried to have a little bit of fun. I really do enjoy the morning ones because afternoon, I just be sitting in if I eat lunch or if I eat too heavy a lunch. Okay, gentlemen, I didn't really write anything except for that one example. So we're going to go with what we have. Are there any burning questions before we go our separate ways? Going once?
Yes.
Yes.
My Pearson code doesn't work.
Where'd you get it from?
I got it from the bookstore thing after I bought my book.
When did you get it?
I got the code today. Well, no, I got the code yesterday. I bought the book 3 days ago, or 4 days ago.
Well, when you go to put the code in, what kind of error message are you getting?
It literally just doesn't work. I put the code in, and it won't let me go any further. It said put the code in the first box, so I tried that, and then it doesn't do anything.
What kind of device are you working on?
A computer, Windows,
Windows? It's not a Mac or anything?
Nah.
Are you able to log in right now?
Log into my Pearson?
Yeah.
Yeah.
When you go to access Pearson, do you go directly to Pearson or do you go through Blackboard?
I go through Blackboard.
Okay, go through there now and try to log in.
All right. My math. Access code. Like immediately says put the access code in. So I copy and paste the access code. Then I click finish and nothing happens.
What does it say on your screen?
It's not saying anything.
Oh, because I'm just trying to make sure that you're putting it in the right spot. Because sometimes they have Course ID. But if you go through like Blackboard, you try to log in, it should be a prompt that pops up.
Yeah, it says access code. So I click it and I go to put it in and then nothing happens.
How many characters is your access code? Or is broken into like, how is it broken up?
It's not broken up.
It's just a long string of random stuff?
Yeah.
Is it typed or is it written?
What you mean?
The access code they gave you, did they type it out or is it written?
So it's on the same page I bought my book on, and it's typed access code.
You bought it. Wait. So did you explain to them that you were trying to get the discount access code?
Yeah, for $100.
You paid $100 for it?
Yep.
And it was inside the book unused? Was the book open? Was it new or used?
I bought the book online on the Morehouse bookstore online.
Was it a new book or a used book?
Digital.
Digital. And it came with a physical copy book, like a physical hard book?
I don't have a physical copy.
You bought like an access code from the Morehouse bookstore and you went to the bookstore and got it yesterday?
No, all right. So look, I went on the Morehouse College bookstore website, and I purchased a digital book, and it said selection rent digital, the 4th edition, and it gives me the ISBN and then the access code.
And then when you type it in, it's just not letting you type it in, or?
Like I can share my screen.
If you're okay with that, yeah. Yeah, that's fine.
All right. Hold on a second.
Let me stop sharing mine. And let me get rid of this.
All right, can you see my screen?
Gentlemen, if you know, you don't have to stay. I'm just trying to get to the bottom of this. And yeah, that's fine. Fisher, is he in this class?
All right, so this is what
I can see it. Okay. Just copy that or put it somewhere else and go to Blackboard. You got to get this working now because this is being streamed, so you don't want somebody to steal it. No. Go to Blackboard.
Yeah, I went to Blackboard.
Okay, yeah. Click there. Yeah.
And it brought me here.
Have you started on, you shouldn't have to register. Can you go back? Like, yeah, I guess when you click on the all assignments, that's where it takes you?
Yeah.
Wait, let me get rid of this. Is there an option for you to log in? Because you should already be registered. I just want to make sure you're getting into the right account. And that might be. Can you like log out? Is there a way to
log out where?
And when you try to type it in there.
Type it in right here? Yeah, it doesn't work.
But I think you have to type it all the way out. Not finish. You got to type it. You're not typing.
I am. Like, DD. You see it?
Yeah, I see it.
All right. Hold on. Let me get the rest of it.
Yeah. Now wait a minute. That doesn't look right though. That's not the right code.
Is that the right code?
Because this is, let me see, 246, 24. This is a 36 character code. So whatever they gave you is not the actual access code. That's not the actual access code. Go back to the access code. Digital ID, 4th edition access code. Click on access content. Redshift access code, login. Just wait, because I don't want your, maybe I need to kind of see this. Let me see who's on the call.